Mm, no.
No question.
I do.
Who was that?
Jada.
What's going on? What's shoot, Jada? What you got?
I just feel like I didn't learn anything. I just looked at the diagram that you had um, from last class and did the
Uh huh.
homework. But I don't feel like I understand the concept, but I can't
Yeah.
say like, oh, I just figured it out on my own, or I guess I felt like I was cheating. That's why I'd asked you all those questions about, I don't know, a formula or something so I could just learn that on my own.
Got you. Got you. Okay. And I got you. I understood your question when you asked. The intent of the exercise was really just to understand the concept. Um, that right there isn't anything that you're going to do or deal with going further. There's going to be a video that we're going to show shortly that's going to round out the understanding of binary and how that's transformed into information. But again, the premise behind that is just for you to understand the concept and going through the exercise. And I understand what you're saying as far as you felt as if you were cheating because you were looking at the chart and then just plugging in the corresponding digits. But
Right.
again, I just want you to understand how characters and numbers are represented in binary by what you type in. That
Okay.
was that was the basis of that first week because again, moving forward, we're not going to work with data at the binary level, but
Okay.
but to understand that that's how data is how it's transferred across the web and how it's stored within a computer is important.
Okay. I was just worried because I'm like, if that's how the classes go, then I'm screwed because
Oh no, oh no,
I don't.
that's just the general. Again, just giving you a basis and an understanding of data and what it is. Because quite often when people think about data, they think about the characters and the numbers. When in our actuality, when it's transferred and when it's stored as ones and zeros. And that's the concept that I'm looking to nail home in that first week. And just again, going to round it off with this video that we're going to kick class off with once the questions are answered.
Okay. Thank you.
No problem. Any other questions? Okay. That being said, I want you guys, if you could, while the presentation's going on, if you can put your phone on mute. That way, no background noises disturb the sound because it's not high quality as it is. Being that I got my cell phone up to the computer. But what the video is about 5 minutes long. It starts off with again our understanding of what binary is, and what it does is it shows how the binary is stored in a database and how it's retrieved from a database. A database is nothing but an extensive array of hard drives, just like your computer, just like your cell phone has a hard drive in it that data is written to. A database is a larger storage unit where information, where data is stored, but it's stored in an organized manner to where it can be retrieved in a more efficient and effective way. So once again, this video is about 5 minutes long. And after the video is complete, we're going to go into understanding um, the data that's stored in the database. And that's going to kick off pretty much week two. So once again, here we go.
memory, or magnetic data storage, is a key component in computer operation. This depends on the ability of magnets to magnetize other materials and the ability of those to retain magnetization until forced to change again by exposure to another magnetic field. Furthermore, an object can be magnetized with the north or south pole at either end. You may already know that data is stored in computers in a series of ones and zeros, a machine language more commonly known as binary code. But how can we represent a 1 and a 0 magnetically? Let's take a look.
A bit is the smallest unit of data storage. It can be visualized as a minuscule block that can be magnetized into a permanent magnet. Every red, blue, or gray block in this picture is a bit. The red blocks have north poles facing up, and the blue blocks have north poles facing down. These are what the computer recognizes as ones and zeros. Gray blocks are the empty bits that have not yet been magnetized. The right head is basically an electromagnet with a core appropriately shaped like this to direct the magnetic field into a bit and magnetize it as it passes by. It can magnetize a bit as a north facing up or a north facing down, simply by changing the direction of the current in the coil. As you may remember from the earlier sections, reversing the direction of current in an electromagnet results in reversing the direction of the magnetic field. Once written, the bits can be read by the read head, which senses the direction of the magnetic field as it goes over a written bit. A hard drive as a whole looks like this. Both the read head and write head are at the tip of the actuator arm. The motor of the disk and the motor of the actuator arm work collaboratively to align a desired bit with the read head or the write head at any given time to read it or write it.
A few years ago, an iPod of this size had the capacity of about 1 gigabyte. But now, a similarly sized iPod has the capacity of about 160 gigabytes. With each passing day, capacity just keeps growing more and more. But have you ever wondered how they can increase the capacity so many times without increasing the size? Let's take a closer look. As we have already seen, magnetics are an essential component to data storage. Research has led to additional applications such as magnetic logic, which will provide more efficient and effective ways of manipulating and storing data. Currently, computers are composed of 3 major sections: processors that control operations and manipulating data, random access memory chips, or RAM, which act as temporary data storage, and the magnetic disk drives that retain information even after power is turned off. Although computers are very complex, they're based on a combination of simple circuits called logic gates. A logic gate is a device that produces a specific output for a given input. There are several different types of logic gates. For example, a type of gate called an AND could be represented by a circuit with 2 switches and a light bulb which only lights up if the first and the second switch are on. If you were to replace the light bulb with a switch controlling the input to another gate, you would have the basis for a more complex system of interconnected gates. In today's computers, logic gates are built from electronic transistors. However, they can be built using many other materials. There are mechanical logic gates based on gears, electromechanical systems based on relays, and even ones based on individual molecules. A critical quality of any logic system is its speed. How quickly does a change in input result in a change in output? Magnetic logic systems can be very fast, and they have an advantage over transistor-based systems. They retain their information even after power is turned off.
Okay. Hello?
Hello?
Okay. Okay. Now that, again, what I tried to do there was round out our understanding of binary and data. So the binary code, the ones and zeros that's transferred across the network or the internet is being magnetized to a hard drive, as you saw in the presentation. So it always maintains its 1 and 0 state, but it's interpreted by the computer or by whatever program we're running to represent what we see. Any questions about that?
No.
No questions? No one?
I don't have any.
I don't have any questions.
Okay. Now, that being said, what we're going to start looking into now is called data types. So we just saw that the data is stored in a database in its binary form. But when that data is stored from a MySQL and any database standpoint, it's stored as a data type. This data type gives it specific characteristics. So what we're going to look at right here are text data types. So when information is stored to a database, once again, as we just noticed, as we just saw, it's stored as binary, but it's interpreted to us in these various formats. These are the various text formats that a MySQL database stores the data as. The first type is a character type. And this is traditionally what we've been talking about when it comes down to the traditional 8-bit byte. It holds a fixed length string, can contain letters, numbers, or special characters. The fixed size is specified in parentheses. Can store up to 255 characters. So as we saw in our previous conversation from last week, the examples that we saw were bytes that were 8 bits long that can hold up to 255 characters. So this character size right here is what we can hold 1 byte in, because it's up to 255 characters. Now the varchar, which is the most popular form of storage for text data types in most database languages, it holds characters, but it holds characters of variable sizes. So it can hold a character of 1, or it can hold a character up to 255. And the storage varies based on the size of that information. Whereas with the character, it's a fixed length. A varchar, it varies based off the size of the data that it stores. So it's a variable length. That's why this is the most common type of text data type, because it varies in size, and thus a database can adjust to the size of the field, because once again it's variable. Whereas with the character, it'll stay fixed at that character size. The next one is a tiny int. It's a tiny text. Holds a string with a maximum of 255 characters. We have a text, which holds a string with a max length of 65,535 characters. We have a blob. A blob is one that tends to hold the largest forms of data types. Medium text holds a string with a maximum length of approximately 16 million characters. So once again, these are MySQL data types that are of text in nature. And once again, this will all round out as we proceed. And here's some more. You got the medium blob, which is slightly smaller. The long text, which again, this holds a maximum length of, this is 4 billion. So this is a longer text string that you can set here. A long blob. Long blob tends to be the ones that we use for the storage of things like video, because once again, it holds up to, this is 4 billion plus data bytes. And these two aren't used that frequently. Let's look at an example here. Let's look at varchar versus char. Now, in this example here, the value for this field is set to a character, which is a fixed value of 4. So in the database, it's going to store it as 4 spaces. The value here is nothing, but it's still going to store 4 spaces in a database. It's going to take up 4 bits in the database. This value that comes in here has 2 characters. So it's still going to store 4 with 2 empty spaces. On the flip side here, with the varchar, once again, it's a varchar with a max of 4, but it's variable in length. So it can hold up to 4, but the storage in the database varies based off the content within a character. Here being null is empty is still 1 byte because 0 represents 1. Here is 3 bytes. But once again, it's variable. It varies based off the data that's coming in, whereas with the character, it doesn't vary. It's always going to store 4 bits regardless of what information is coming in. In this example, it's more than 4, but we've set this field type to be character with the max of 4, up to 4. So here it's only going to store the first 4 that comes into the database. This is important. Is also why varchar is used more frequently than character, because you can save storage space in the database because you can vary the space that's being allocated for text when you utilize the varchar. And here's an example. If you had an 8-character text string come in, which is equivalent to 8 bytes, and say you have 8 million records. So once again, it's just one value that's stored 8 million times, but it's a size 8. It's going to require 8 million bytes to store that record. And this is the equivalent megabyte storage in the database. Where if you chose to use varchar, and if it came in, you have 8 characters, but it's really only 4 with the million records. It varied in size, and it only was equivalent to 4 million bytes, and the storage space is cut in half. So once again, this is an example of, on the database side, when you store information in varchar versus char, One is fixed and one is variable. Next data type that we'll get in is numbers. Numbers are stored in the database as these various data types. Tiny int. And once again, the parentheses here indicates the maximum amount that you can store. Even though we see here that it's from -128 to 127, you can set the maximum here. So if you only want to store 10, you save it as a tiny int with the size 10. Which you go back to the example here, it was a character, and we was forcing it to only store 4 bytes in the character, even though the value came in with more than 4 bytes. You only store 4 bytes. So you set a maximum when you put a value within parentheses. Small int, and this is the range in which a small int needs to be stored as. So if it's a number that's between -32,000 plus and positive 32,767, is stored as a small int. Medium int, number range. The most popular number data type is int, because you can store up to a certain value. Used more frequently than medium int, because again, medium int doesn't go above 1.6 million. And quite often you have numbers that's larger than 1.6 million. So again, the int size is the most common one used. But say you know specifically that a number is within this range and no larger than that, you will use this size, understanding that if you use this one, the database could use up more storage than necessary. And you have the big int, which once again, the numbers are even more long, astronomical. Any idea what this number represents in binary? Any guesses? Once again, it's a number that'll fit within one of the number sizes here, but it would not fit in others. So let's check it out. So far, what we've done is work with binary up to a certain value, 8-bit and 128. In order to represent larger numbers, what we do is use more bytes. So instead of using 8 bits, we use 32 bits. So it's not 1 byte or 8 bits. It's 32 bits or 4 bytes. So what the computer does is it not only sends these two, it sends more to represent larger numbers. So this 32-bit can go as far as in representing numbers. So as you see here, Each flip of a bit represents a larger number. So in a previous example, when I asked about this number here, that number in binary is equivalent to 1 million. So this is the binary representation of 1 million that would fit within a medium int size. It wouldn't fit within a small int because that number of 1 million is larger than the 65,000 that's allotted. But it fits within this size type, which is 1.6 million, which is within the range to 1 million. So this is how you represent larger numbers in binary and how larger numbers are stored in a database in binary. So 1 million is represented this way in binary, which is of this data type. Any questions? No. Proceed.
I don't have any questions, but it's kind of confusing. I'm trying to get it.
Yeah, and once again, this is something that you need to memorize, because once we get into the database, which I'll show you in a second, it'll all make sense. These are just descriptions of the various data types that you can store in a database, which you'll see, and then all round out very shortly.
Okay.
A float is a data type that we use to represent dollar values because it allows for a decimal. What you have is the number, comma, the numbers in decimal. A double and a decimal itself. The last of the data types are date types. Once again, you store the data in a database as a various type, and these are the various date types that you can store data as. Date, which is the regular year, month, date format. Date time, which is the date, hours, minutes, and seconds. Timestamp, which is the same with the year, month, and date stored in the hour, minute, and second format, but it's stored in seconds. Time is strictly time, hours, minutes, and seconds, and year can be stored in 2-digit or 4-digit format. Now, this is what we get into. Okay, now, a couple of you were in previous classes and may have Toad already installed. Those of you who do not, you'll have to download Toad. Toad is freeware that you download, and it's the software that interacts with the database, so it engages with the database. You have the link. In order to download it, you have to register with Dell for a free account to get access to the free download. So what we're going to do now is go into Toad, and I'm going to show you an example, and once again, it'll all round out and it'll all make sense. But once again, Toad is the freeware that you need to download in order to engage with the database. Okay. We're going to talk a little bit about the homework assignment, which is going to lead into the tutorial. The tutorial is going to be me showing you exactly what you're going to be doing during the homework assignment, which again is going to round out what we just spoke about with data types, character, number, and date. But these are some of the requirements that we're going to have, some of the steps in order to get you guys access to the database. So once you get the link or get the email for the homework assignment, I will need you to send your computer's IP address to this email address. Now, to get the computer's IP address, you can go to a website. Whatismyipaddress.com is one. What is my IP? And it'll tell you. It's mine is not different, but it'll tell you what your IP address is. And just email me your IP address. What IP address does and why it's significant is a database has certain levels of security within it. And in order for a certain computer to access the database, the IP has to have authorization to enter it. So I need the IP address from your computer in order to give you access to the database environment, which we're going to go into now. Okay. So we have Toad. Once you install Toad, this is what the interface is going to look like. In addition to getting a homework assignment, I'll have some video tutorials that walks you through the same steps that I'm about to go through now. So don't think that you have to memorize or get everything now, because there'll be videos online that'll walk you through the same steps that you're about to do now. That's going to be part of your homework assignment. Okay, so here we go. Within Toad, you have what's called the Connection Manager. The Connection Manager allows you to create connections to a database. Here is the icon for a new connection. So when you install Toad on your computer, you have to create a new connection, and this is the dialog box that'll pop up. The first two parameters stay the same, and these parameters will change. And these parameters will be given to you within an email with your login credentials to the database. So you'll be given the host, which is the IP address to the database. You'll be given a username, and you'll be given a password. Once you make this new connection, you save it, and it will appear on the right side here under connection. Once you've established the connection to the database, it's always here, and you can always right-click and connect to the database. So I'm going to connect here. Once again, it's important that once you send me the IP address, I'll in return send you the credentials that you need to make your connection to the database. And you'll do it by creating a new connection and once again entering your credentials within the dialog box that was just displayed. Once you make the connection, down here in the Object Explorer, you'll be able to select the various databases that your username has access to. When you log in, you have access to only one database, and it'll be the iThinkInfo database. Initially, once you log in, your database will be empty. Your homework assignment is going to be to populate your database with data. I'm going to show you how that's done here. So once you've connected to your database, you're going to go to the Tools option. You're going to import. With import, you're importing data from an external source into the database environment. There's an import wizard with the option that you select. Once again, that'll be a tutorial that'll take you step by step through it. So you don't have to memorize. I just want you to understand it. When the wizard opens up, next, we're going to add a file. Kind of technical difficulties here. Where's that one? My apologies. Toad. Them. All right, let's try this again. My apologies. Once again, you connect, the connection is saved, so it's always there. You choose a database. And the only database that you see are the ones that you either have access to, and the only one that'll pop up for you at this point would be the iThinkInfo. Once you're connected, again, when going to Tools, the importing data, import wizard. Next. Okay. The file that you're going to need, I'm going to send to you. In this case, it's going to be homework 2 data sets. When you open the file, it's an Excel-based file. And the Excel-based file has numerous tabs to it. Each tab comes up as a sheet. You select each tab, and each tab shows you the content within the spreadsheet. So in this case, this spreadsheet, or the tab device with the spreadsheet, has the domain name, the source, medium, the device type, date, page views, user, and new users. And what this information represents is visits to a website. So for this domain, this was the source of the traffic. The device type, of the visitor, the date, the number of page views, the number of users, and the number of new users. This is the data that we're importing to the database. This shows you an example. In this window, you designate what table within the database you want the information stored. In this example, we want to create a new database. If there is an existing database that we were looking to import data into, you will be able to select it here. But there's no tables up in there right now. So we're going to create a new table, and you're going to name it, table name. Hit next, finish. And the system is going to import the data from that tab into the database. It tells you that it read 152 rows from the spreadsheet and imported 152 rows in the spreadsheet. Hit OK. And over here now you see your table. We created the table domain, device, table. In this pane view, you can see the columns of the table, and you see the type of the data contained. For the purposes of this, I'm going to open up the spreadsheet that we just imported so you guys can see the data. So this is the spreadsheet and the data that we're importing into the database with the various tabs that we just saw, with the content in each tab. So what we just imported from this Excel spreadsheet was device category. So it's the device tab. So the data within the spreadsheet, each column represents an attribute of a record. This is a record. These are the attributes. These are the attributes of each record. So when we did an import, code recognized the format of each field that was being imported. It recognized that this is all characters. So here, it represented this. It recognized this is a date, and these as integers. So on import, it assigned that data type to each of those columns. So for domain, which is of character type, it assigned to the variable of varchar with a maximum of 50 characters. And it set the maximum as 50 characters because it analyzed the content of that column and it realized, okay, that there was no values in here larger than 50. So it set the value to 50. For this field, it set the value to 69. Again, based off of content of the spreadsheet. For device category, smaller field, it's set it at 50. The date field, it recognized as a date and set the type as a date. And for the 3 integers, it set them as integers. Now, simply because it set those values as this doesn't mean that they have to stay as those values, because quite often you can get other data sets that's larger than this. So we can alter these values, and we'll alter these values later on within the program. So this is one example of importing data from a spreadsheet, device tab, into a database, creating a table called domain device table. Now I'll do it again, another example. Now what's important when you're doing this is that your source of the data is always closed. If you try to import data from an open file, you get an error, which we'll do it for the fun of it. Import. Now again, my source file is open right now. So I'm going to try to import data from that file. And it's not going to let me, because I'm reading a data file that's open. So I have to close it. Okay, let's try again. Import wizard. Again, takes you through the steps, add a file, locate the file that contains the data. Within the sheets, locate the tab that you're looking to import data from. We already did device. Let's do landing, the first one. Within landing, the field headers are assigned by the top header from the spreadsheet. So within the spreadsheet itself, whatever the top header is set to is what, I can't open that up. Yeah. Whatever the top header is set to is what it saves the column name as in the database. So since this column header is called source/medium, in the database, the field name is source/medium. Okay, so we're going to import the landing sheet tab within that data source. This is an example. Once again, we're not going to use an existing table, even though now there's one there because we created it earlier. We're not going to store it in that table. We're going to create a new one. This is landing information, so I labeled the table domain landing table. Next. Finish. It's going to import the information. It'll tell you that it finished, and it imported the exact number of records that it read. Quite often, it'll say it imported less numbers than it read, and in that case, something went wrong, and you'll have to roll back or delete the information that was put in. But most times, for the purposes of the tutorials, you won't have any situations that the data that each row wouldn't be read in. So now we have the landing table with the data from that tab now saved in the database with the field name column headers, the data type assigned, and the data. Do it again. The source tab. They read 171 records, imported 171 records. So everything imported successfully. And now we have a source table within the database. So your homework assignment is going to be to populate your own sets of tables within your own database. Your tables and the data within is what you're going to use in the subsequent weeks to learn the SQL programming language against. So now that we have these tables within this database populated with data, we can then begin creating SQL statements against the data within the database. So going back to your homework assignment, once I receive the IP address, you'll receive your login credentials. You'll receive the email with the relevant homework details, and you'll have links to a tutorial on connecting to the database and one on importing into a database. And then you'll have to populate your database with said data sets and create said tables. Again, I just did an example of 3 data sets, create 3 tables from a spreadsheet. So you're going to have the exact same spreadsheet, and you're going to create your tables. That's going to be the basis of your training moving forward with the data sets that you get. Any questions?
I have no idea what just happened.
Okay. Who was that?
Jada. Am I the only one? Like, am I slow?
No.
Oh, like what the hell?
I told him 30 minutes ago. I don't know what's going on. I'm trying to get it.
Okay, no, and that's why we need questions again. Let's go. I want the questions so you guys can understand. So
I don't know how to ask a question about what happened.
No. Okay. Let's do it this way. Now we have the spreadsheet, right? Okay, so say you're at work, right, and you have data in a spreadsheet. The goal of a database, or the goal, is to get the information from a spreadsheet, from a text file, from an email, from any type of data source into a database. So when you go and you send a text message to somebody, that information ultimately lands within a table in a database. It's just that the source of the data is your cell phone. Whereas here, the source of the data is this spreadsheet. Data?
Yeah.
Did you get that?
I got that. I just.
No. We're gonna build on that though. I want you to get that first, and we're gonna build on that. So the purpose of a database is to store data, regardless of what the source of the data is. In this example, our source just happens to be a spreadsheet. It could have been a phone call. It could have been a text message. It could have been a bank transaction. When you perform a bank transaction at an ATM machine, it's gonna, even though you perform an action at that teller or at the machine, it's gonna read the information from this database. So the database holds all the relevant information to perform your Facebook transactions. Everything is contained within the database.
Mm-hmm.
The spreadsheet is just one example of a data source and getting it into a database.
So I get that conceptually,
Uh-huh.
right? So if I read it, like, okay, that makes sense. But I still don't understand how to translate that into the homework assignment, or maybe I'm not understanding.
Okay. Now, what you're going to do is, the homework assignment is you're going to do exactly what I just did. So you're going to have your own spreadsheet. That's going to be your data source. You're going to get a link to the spreadsheet within the homework email, and that's going to be your data source. Your data source could have been the spreadsheet. It could have been an email, again, a text message. But in this example, also our data source is the Excel spreadsheet. We could use a text file, but again, for this example, it's going to be a spreadsheet. If you look here, if you go File, Import Wizard, and at the Add File option, you could have added files of various formats. So it's not just Excel files that you could import. You could have imported other text files and other file types as well. It's just, again, for this example, an Excel spreadsheet is our data source data type. So you're going to get an Excel spreadsheet it's just this exact spreadsheet. It's going to come with X number of tabs that contains different pieces of information about visits to a domain. So when people go to a website, this is the website, this is where they came from. Let's use this one. Let's use this one today. Okay. This is on this data set on the day tab. The data that we have is the domain, the source, so where it came from, the day of the week, the day, the number of times that page was viewed, number of users and new users. So this is information that we're going to import into our database. And we'll make sense of the data of this information later. Don't worry about that right now. That's the power of SQL. With SQL, what we'll do is we'll analyze this data. So we'll be able to tell a client of a specific domain name on what day they received the most views, the most new users, or we'll be able to tell them on what day and what hour is the most active for them. So they'll be able to focus their marketing dollars on that day and that time, and we can even get more specific down to where the user came from, the type of mobile device the user used. So when the client starts to market their services or their product to potential clients, they know various demographics about the clients, so they have a better idea where to focus their dollars. So what we'll do is we analyze this data so that it makes sense for the client. This record is a single day. With SQL allows you to analyze periods of time. So we'll have 1 million records, but with SQL, you can analyze those records to make sense of all of it and give the client an answer. And that's what SQL does. SQL works against data. And most companies, the company you work at right now, has mounds and mounds of data that can give them answers to questions that they need. But they have no way of analyzing that data. What I'm teaching in this program is how to analyze data. It can be financial.
Maybe confused on an assignment. Like, I can look at this and easily tell if somebody was asking me what happened on the 14th at midnight. Okay, 65 page reviews. You have four users, and all of those users were new users. Like, I get that. I just don't, or maybe I'm jumping ahead because I'm like, well, what is the assignment? Am I supposed to?
Nah.
Is this I can look at and I get it based upon being given a question. I just don't understand what I'm actually supposed to be doing. I see your arrow and you're clicking, and I can read that. Those are words and numbers, and I get it.
Got you. Your assignment is to get you to where your database is populated with this information like this one is.
Yeah. Okay.
Right now, honestly, real. You'll get it. Because if I delete it, I can delete all these tables right now. And once I delete it, it's gone. So my job is to go through the same process and pull all that information back into the database.
Oh,
so
my
what
God.
you saw before, you don't see no more. It's gone now. So your homework assignment was to bring that data from that spreadsheet back into your database. Because what you're doing is you're creating the basis of the learning. You have a data set that then you can use SQL. The SQL that's the bulk of the program is learning SQL, understanding the code necessary to analyze any data set, whether it's weather, whether it's fashion. Any industry relies on information. I challenge you to find an industry where information can't be used to further that industry. Again, whether it's weather, analyzing weather patterns, whether it's a store, analyzing trends in sales, understanding who their best customers are. That data is contained within the database. So as a data analyst, as a data scientist, our job is to understand the information that a company has and how to make sense of it. Now, most data analysts, they don't understand this part that I just showed you now. They work from, okay, the data's already in a database. Let me write some SQL to analyze the data. As a data scientist, I want you to understand not only how to analyze data, but I want you to understand how to get data, how it gets into a database, but even further than that, I want you to philosophically understand what data is. It's not S's and ones and twos. It is ones, but it's ones and zeros. That's all data at the base level is, and it's stored in a database. And what I'm showing you now is how we interact with the database. We just imported information from a data source. This source just happens to be a spreadsheet. Again, a source can be anything. It can be a telephone call. It can be an email. It's ultimately stored in the database. When you send a text message, when you use Gmail, that text message, that data is stored within a database that's associated to you. And when you open up Gmail, it reads the data from tables in this database or their database and presents it to you on the screen as characters, even though it's stored in the database as ones and zeros. So the first 2 weeks, the purpose was to get you to understand exactly what data is. But now I want to introduce you to a database. We're going to get more into databases as we move on. I think week 6 and 7 or 5 and 6 is focused on MySQL databases. But this is just an introduction because it's necessary for you to be able to do your homework assignment. Did that help, Jada?
I just want
I hope it did.
I don't know. Maybe I'm overthinking it, and I just need to see.
No, you are.
Because
you are. And again, this part is simple. It is. You are overthinking it. Knowing you, me knowing you, you are very philosophical. Philosophical. You are overthinking it. All you want to do is import data into a database. I'm going to send you a spreadsheet. Again, before you get the spreadsheet, you have to download Toad. Because Toad, go ahead.
So the computer I'm using now is with my gig, and I'm sorry, y'all, about this question.
No, go ahead.
My job, but it looks like I'm about to have a new job in a week or two, which means I'll be purchasing my own computer. So will this mess me up in doing this part of our assignment using my current work computer, and then for the rest of the time that we're doing this class, I will be using a different one?
Nope, because but you have to download the software on each computer.
Yeah,
so,
I get. Okay.
Yeah, because all the software is doing is just a software. The connection is what's important. You being able to connect. Now, what may happen is you change computers, your IP address will change.
Right, of course.
And you'll have to give me the new IP address, so I allow that computer access to the database. But aside from that, everything else will be the same. You wouldn't need to change anything else.
Okay.
Yeah, but again, the purpose of this first is just to import data into a database, and then as we proceed, we're going to start analyzing the data using SQL. SQL is the programming language of databases to analyze information. And again, we're looking at an example of traffic to a domain name. There's countless, anything that you can think of that you see on a TV, you see on a computer, a smartphone, is data that's stored in the database. So when it comes down to fields like legal fields, the automotive field, I've worked for 8 or 9 different companies working in different data areas, from real estate to supply chain to right now I'm working in a company called Fuel Tech, where they manufacture and they make certain type of equipment more effective, but it's the data behind that. So data is data. Regardless of what the source of the data is, it's stored in the database, and the world needs people to understand what the data is saying. Within the medical field, there's years and years of data out there that the doctors can't understand because they have no way of analyzing it. There's opportunities to analyze data to understand historical trends, but to better understand the cause and effect of things. If I, as a business owner, if I went out and campaigned a certain product in a certain geographical location for a month, I need a way to gauge how that campaign went. Aside from people coming into the store, because ultimately there could be instances where people didn't come. But I need a way to gauge that. And data is the way. If it's sales, people that come in and make purchases, you can use the data to see in what periods did I do certain marketing programs, did it generate more revenue? Or from a website standpoint, in what periods did I put on a certain campaign in the Chicagoland area, did that increase traffic to my website? And if it did the people stay on my website? If they didn't, why not? Maybe I should design my web page slightly different to make it more appeasing to the end user. It's insights like that that you get from data. Without data, you wouldn't know. You would have no way of having people that sit at a terminal to monitor each person that visits a website. But through the use of data and information and our ability to write SQL to analyze tons and tons of information, you can provide business owners with insight that they typically can't get at. Most of them don't even realize that it's there. And that's where the opportunity for iThinkInfo participants and InfoMaple to make a mark within the industry, particularly within the urban industry. There's not many companies, if any companies, analyzing data, making sense of data in order to make businesses more efficient, make healthcare make more sense. There's tons of data out there to be analyzed. And through this program, I'm looking to teach people the necessary skill sets to analyze data so that some of the questions can be answered. Any other questions, Tammy? Any questions?
Nope, not right now.
Not Terry?
I'm going to try to do this assignment.
Yeah, you're gonna be once again. All we're doing is importing. You'll get the spreadsheet. As long as Toad is installed, you'll get your logon credentials. Once you get that, you put them in. Again, I'm gonna put together a video with me doing what I just did over and over again, so you guys can see that. And then once it's in there, it's in there. And then next week we'll start learning SQL, and we'll start analyzing that data. Even though, like Jada mentioned, you can see a given day and what the data looks like. What if you want to look at 3 months? I don't want to look at what happened on a given day. I want to look at the past. I want to look at the past 3 months and see what type of traffic a specific data source that I'm paying for. Let me go back here again. I just want to reiterate the example that we have. So I'm importing data from the spreadsheet. The same spreadsheet you guys will have is open. Once again, I didn't check. Right. And once again, there'll be a video for this, so you guys don't be concerned about me flying through. I just want to get some data in real fast.
I have a question right there, Robert.
Go ahead, please. Was it a question during one of the steps? Did you have a question during one of the steps here? Hello?
Are you there?
It's a mobile. A new table. Now, I'm going to show you this because we're here. Right here, and this will be important later, much later. You can automate this process. And this is what most companies do. Say, for example, you have data files that's constantly being put somewhere. You can automate the picking up of a file from a location. So as opposed to somebody sitting down and manually going through this over and over again, you can automate this process, which is how it's done in the industry. You've got data being dropped at various locations, and you have programs going to pick data up through an automated process and dumping it into a database. And we're just going through this so you guys can understand what's being done, and later you can automate that process. So this example right here, this is the mobile table. So it contains the domain that the traffic was going to, the source. So this is a Facebook referral, a mobile device, and there's an iPhone, number of views, users and new users. So this is telling me that on this day, a Facebook referral sent somebody from an iPhone, and this is the number of page views that I received. One of the users, well, 4 of the users were new because there was 5 total users, but 4 were new. So on this day, that's the piece of information that I gathered. What we do is analyze this stuff over a larger period of time. So if your purpose is to campaign to iPhone users through Facebook, we can tell you how well that's doing based off information. And that's why we're getting the data into the database. And once it's there, our projects moving forward is going to be about analyzing this stuff to make sense. But you guys will learn the SQL code necessary to do that. Any questions? I know some more questions. Javon, any more questions?
Robert.
Go ahead.
Robert, this
Please.
is Kerry. Is the
Please.
version of Toad that I have 7.5 already?
I'm sorry?
Is the version of Toad that we already have 7.5?
It is. The newest version is 7.5. I have 7.3. But
Okay.
the newest version is 7.5 out there right now.
Okay. And another question. When you were typing in the table name, I couldn't see to the far left of that field. I couldn't see all of the fields. Does that say domain, or are you typing in?
I was typing in domain. You're right.
Domain.
There's something with Toad, and you're gonna experience the same thing. When you're doing that, it doesn't show the first left-hand side. Nope. Okay. So I'll show you with that. So I have to be careful of what I'm typing in, because otherwise you create a table that's not what you want it to be, and you have to redo it.
Okay.
So let's do it by. You can do browser type, so you know what browser type the user came in on. And again, it may not seem as pertinent information, but to a company that's spending $1 million to to market to a certain demographic, that information is pretty useful.
Right.
See, it's the same thing here.
Okay.
You can't expand it either, so you just got to know the first part you can't see, but as you start, like the first 3 characters is cut off.
Okay.
Not error. They tell you if there's an error message in the word, so it knows, so don't bring it in and try it again. They tell you when to air it out, finish with errors, it read 250, then import any. So,
Okay.
Javon. Yep, Javon, down to the mobile user type. You can tell what type of phone the user was using when they went to the website with that data set. Again, that's the purpose of databases. Without a database, it's almost impossible to analyze extremely large data sets of data. I have other data sets here. I'll show you the examples of them within some of my databases. From a political standpoint, I'm analyzing some data within the city of Chicago. So we have data on voters, registered voters, surveys they've taken, and candidates they favored, and their responses. So this is data from an individual voter on the candidate that they favored, and if they decided or undecided on them. And this data is analyzed to help the politicians running for office better target and better spend their dollars to target people who are more likely to vote for them. You have some candidates who may be looking for people who are not likely and try to convert them, but most candidates are looking for people who are more likely to vote for them and focus their efforts on those particular people. So some of these tables can get up to 1 million records. And again, to sit here and try to look at each record and analyze them individually, it's impossible. Like I have data from Chicago Data Portal of Crime, and it contains each crime that happened in Chicago on a city block, what date and time, and what the offense was. If an arrest was made, the XY coordinates of the arrest. So what you can do with this data is analyze it holistically to understand what crimes have happened more frequently than others in certain geographical locations. And with data, you can do that. Without data, I guess you can go off physical record maybe, but within a database, it gives you the power to make sense of all this. This record right here this table contains 27,000 records. That's not a lot. But I have some in here that's 1 million records long. These are building violations, sex offenders. But this is information that is actually free. The city has a portal that they hand this information out to. And I mentioned to you before, I showed you the presentation where the president was talking about how they got this a big initiative to give out information for people to make sense of. That's what I do. That's what InfoMaple does. It goes out and acquires information that's given to the public, and we make sense of it. And once we make sense of it, we bring value to it, and we take it to the people who need it the most. This one right here is a project I'm working on right now. It's, again, from the same portal from Chicago. They provide this data for free. It's building violations. is every building violation that happens in the city of Chicago, the violation, the address of the violation, inspector-related information. But what we're going to do is analyze this information to associate, based off address, a violation to a registered voter. Once you make that correlation between the two, the record here and the registered voter, there's going to be a business generated to go out and market to those voters whatever the building violation is. So if it's a repair exterior wall, there'll be somebody who knows how to repair exterior walls that's going to go out to that particular person and market that service to them because it's a known building violation. The city's not doing much with that information, but we will. And it's the use of information like that, making sense of information like that to create opportunities from. And that's the purpose of information. Information made simple, regardless of what the information is. Any other questions? And again, this right here is like the end state. Once you guys are done, you'll get to the point where you can go through stuff, tables like this, and make sense of them. But right now, we're working on specific data sets that you guys are going to bring into the database. And once it's in there, we're going to start connecting tables together to make sense of multiple tables. Because one table may have one piece of information about a person that you get from, say, Facebook, but another table may have something else that you get from Twitter. And if you want to really bring power to your understanding about that person, you connect those two pieces of information together and make sense of what that person's really thinking. Not only from Facebook, but also from Twitter. And that's what a database does. It brings information from different sources, connects them together to create a picture that you can then create knowledge from. Any other questions? Shoot. Any question?
No, I don't have any more.
More questions? Javon, no questions? Tammy, you good?
Good.
Gary?
Yes, I'm good.
Straight? Tyrone, any questions? Okay. So, next step, again, I'm actually going to send you guys the homework email out initially. And once you get the homework email, I'll stay on there to respond back with your IP address. And once I get your IP address, I'll set the IP address up and plus create your credentials for you to be able to log on and start creating the tables within your database that we're going to use next week in our learnings of SQL. That being said, you guys have a wonderful evening.
You too.
And have fun with the data.
Sure.
Thank you.
We think info.
Yes.
Okay.
Y'all take it easy.
All right. Bye.